Good morning everyone. In our last lecture, we have seen a law of gravitation, universal law of gravitation, and also we have derived the equation for the gravitational force. You know that what is the equation? It is a F is equal to G m1 m2 by d square, where the m1 and m2 are the masses of two objects and this is the distance between the two objects. As the universal law says that in universe every object attracts each other. So the gravitational force is along all the objects, right? As you know that I also attract the things which are present near to me. Like that you are also attracting some of the things, right? So according to the universal law of gravitation, between every object there is one attraction force, and we are using this equation, a derived equation, which is F is equal to G m1 m2 by r square over d square. If you take a distance as a d or a r, right? So the F is equal to G m1 m2 by d square, right? We are using this equation for calculating a gravitational force between the two objects. It can be a celestial object or the object nearer to you, means the object present on a earth, right? As you know that according to universal law, every object attracts each other, means the object which are near to us like a fan, tube lights, tables can also attract each other. Not only that, the celestial objects like the sun, moon, earth, Mars, Jupiter, all the objects also attract each other with the help of some of the gravitational force. Then today we are going to learn how to calculate this gravitational force, and for that we are using a simple equation, only one equation, which is F is equal to G m1 m2 by d square. But the most important thing is that these sums are not will come in your exam, because it has a very big calculation, right? There is a larger number. You have to multiply and divide a larger numbers, right? And which is the very time consuming technique. So just because of that, and also the calculators are not allowed in our exams, right? So these type of calculations are very time consuming, and just because of that, these type of sums cannot become in your exam. So as a point of view exam, these sums are not most important or important for you, but as the learning object, it is a most important, because as you know that you are just coming here for learning something, not only for obtaining marks, right? Only for obtaining your marks, then you can skip this video, right? But if you want to really learn something, then you have to just watch this video carefully, because today we are going to see how the gravitational force can be calculated between the two objects if the mass of an object and the distance between both of them is known by us, right? These questions are not important according to the exam point of view, but as you know that we are learning, so as a point of view of learning, you have to watch this video, because there is a large calculation according to it. Not only that, how to calculate this larger one, you have to divide and rule. We are using this type of rules in it also, so just watch it carefully, right? So for that we are going to see the first sum, example 10.1, right? In your book there is an example 10.1. What is given to you? The mass of Earth is 6 into 10 raised to 24 kg. The mass of an Earth is given to you, and the mass of Moon is 7.4 into 10 raised to 22 kg. If the distance between Earth and Moon is 3.84 into 10 raised to 5 km, then what is the gravitational force applied by Earth on the Moon? Means you have to calculate the gravitational force. As you know that for the gravitational force, there should be a two object, because the gravitational force is always acts on two objects, between two objects. So there should be a two object. What are the object in this example? So there is a two object, which is Earth and the Moon. And for finding the gravitational force, we need to know the masses of both the object and the distance between both the object, which is given to you in your exam, right? So the mass of an object 1, which is Earth, if we take it as a ME, E for Earth, right? So the example 10.1 ME, mass of Earth. If it is 6 into 10 raised to 24 kg. I am just taking this M as a capital, right? So capital M E, right? Which is 6 into 10 raised to 24 kg. And the mass of moon, if I am taking as a M, then it is 7.4 into 10 raised to 22 kg. And the distance between Earth and moon is, the distance is taken as D, which is 3.84 into 10 raised to 5 kilometer. You have to convert this kilometer into meter, so it's a 3.84 10 raised to 5. You have to multiply by 1000, so it gives you a 3.84 into 10 raised to 5. 1000 means it's a 10 raised to 3, so it gives you 3.84 into 10 raised to 8 meter. So distance is given to you. Not only that, the value of G is also given to you, capital G, a gravitational constant, right? Which is 6.7 into 10 raised to minus 11 Newton meter square kg raised to minus 2. As you know that the real value is 6.673 into 10 raised to minus 11. But according to our example, they are giving us 6.7. So we are using this value, right? So these are the values. Now we have to find out the F, right? The gravitational force. So what is F? As you know that for that you have to apply the equation. F is equal to capital G ME M divided by B square. The value of G is 6.7 into 10 raised to minus 11. ME is 6 into 10 raised to 24. MM is 7.4 into 10 raised to 22. Divided by D square means it's a 3.84 into 10 raised to 8 whole square. At here you have to take a 6.7 into 6 into 7.4. And as these are multiplication, you have to just add all the powers, right? Then it gives you 10 raised to 24 plus 22 minus 11. Here the plus, right? Divide by. Now you have to take the square of it. What you have to do? You have to just write 2 times, right? Then it gives you a square. So you have to just write a 2 times, right? Now it's a 6.7 into 6 into 7.4. It is a 10 raised to. What will be the value? The value is 35. Divide by 3.84 into 3.84. And this is a 10 raised to 16. Right? Now, what you have to do? Now, these are as a division, so power should be subtracted. Right? So it gives you a 6.7, 6 into 7.4. 10 raised to 35 minus 60. Divide by 3.84 into 3.80. Then what will be the answer? 6.7 into 6 into 7.4 into 10 raised to. The value is 90. Divide by 3.84 into 3.84. Now we are just removing the point. Then it becomes 67. Then you have to write 10, 6, 74. Then 10 raised to 9. 384. Then you have to write at here 100, right? We need some more space. here is equal to 67, 6, 74, 10 raised to 90. For 67, 10, 74. 384, then you have to multiply by 100. 384, then you have to multiply by 100. These 100 and these 100 are cancelled out. Then it gives you, now 67 into 6 gives you a 402. While this 74 and 100 gives you a 7400 into 10 raised to 90. Divide by 384 into 384. Now you have to just divide and roll. Means 402 divide by 384 into 7400 divide by 384 into 10 raised to 90. If you divide and roll, then it becomes easy for you, because if you just multiply both of them and this one, then the division is very hard for you. So just divide it. Then you can easily do that, because these two are same. So you have to just write a table of 384 and you can put the value of it and you can easily calculate this value, right? So you have to just divide. Then it gives you a 1.04. And what will be the value of this? This gives you a 19.27 into 10 raised to 90. If you just multiply it, then it gives you 20.0408 into 10 raised to 90. So the value is 2.004 into 10 raised to 20. So here is the value of f. So like that you can calculate that. As you know that, okay, we can do at here, it is easy for you till, right? But after that, okay, now it is also easy. If you remove the point, then it can be easy also. If you multiply, then also okay. But at here, the divisions are very hard for us, because these numbers are very large. For that, we have to just give so much time for it. And the main thing is that, is it right or wrong, is also does not known by us. And we can't just do again this work for knowing is it right or not, right? So it is very time consuming from this step, right? Only there is a 2 to 3 step, but it is much time consuming. And just because of that, these sums cannot be asked you in your exam. Just see it, right? The simple thing is that all things are given to you and you have to just put the value of it. As you put the value, you have to take these powered integers, you have to take in the one side. Then it gives you a plus or a minus according to the multiplication or a division. Then as it happens, then you have to just remove all the powers and it gives you only one, right? Of one power term, right? After that you have to remove the points of it. Then you have to just multiply some of the terms and then division, right? It is the simple thing related to it. Main thing is that you have to just see and try to understand how I just do them, because these ones are very time consuming, of course, and the calculations are also very hard. Just because of that, it can be asked you in your exam. But as a learning process, you have to just see it carefully, because it gives you how to calculate this type of larger calculation, right? It helps you in your maths also. So please just see it and try to do this division by your own self, right? Do not try to just write or just see and write like that. Okay, you have to try it by your own self. Is it right or not? You have to also see that, right? So please watch this sum carefully. Now there is another example, right? The example is from exercise, okay? What is the example? From the exercise there is a question number 3. calculate the gravitational force of an object of 1 kg mass which is situated on the surface of Earth. If the mass of an Earth is 6 into 10 raised to 24 kg and the radius of Earth is 6.4 into 10 raised to 6 meter, take a G as a 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. Okay, there is a two object. One is a Earth and another one is just situated on the Earth like that. Here it is Earth and here it is one object. Right? The mass of object and the Earth is given to you, and the radius of Earth is given to you, which can be the distance between Earth and the object. So there is everything is given to you and you can easily calculate the sum. Just a time consuming problem. Right? The main problem is just time consuming. Otherwise it is a very easy and it gives you a good how to calculate anything. Right? Because the calculations are hard, but it improves your maths also. Generally we are just do some of the mistakes in multiplication and division, right? So these mistakes can be removed by calculating this type of sums, right? Okay, now so there is a two object in which the mass of an Earth, if I am taking as a M, capital M, right? Because there is no Earth and Moon and something like that, only one celestial object. So I am taking that celestial object as a capital M. So it is a capital M which is 6 into 10 raised to 24 kg. Right? For the object's mass, I am taking a small m which is a 1 kg. Okay? Then the radius is I have taken a distance which is 6.4 into 10 raised to 6 meter. It is in meter, so we does not need to what we can say that convert it, right? And the G is given to you which is 6.673 into 10 raised to minus 11 Newton meter square kg raised to minus 2. You have to calculate F. The F is capital G, capital M small m divided by D square. Okay? So the G is 6.673 into 10 raised to minus 11. The capital M is 6 into 10 raised to 24 while the small m is 1. And the D is 6.4 into 10 raised to 6 whole square. Remember this square, okay? Generally forget it, okay? So now 6.673 into 6. Take this power term in the another side. Then it is a multiplication, so you have to just add both of them. This one is minus, so I am taking a minus, right? Divide by. Square means you have to write it 2 times. Okay? Now 6.673 into 6. It gives you 10 raised to 30. Okay? Divide by 6.4 into 6.4. These one are also added as a multiplication. So it gives you 10 raised to 12. 6 plus 6, 12. Right? Now both are in division. So the power will be minus from each other. Then it is a 13 minus 12. Divide by 6.4 into 6.4. Right? 6.673 into 6 into 10 raised to 13 minus 12 means it's a 10 raised to 1, right? Divide by 6.4 into 6.4. Now I am removing the point. Then divide by 1000, 6 into 10. At here 64, then 10. At 64, then also 10. These zeros are cancelled out, right? So it gives you 6673 into 6 divided by 64 into 64. If you multiply both of them, then it gives you 40038. Divided by 64 into 64 gives you 4096. If you just divide it, then it gives you 9.77 Newton. So the value of force is 9.77 Newton. So here it is the sums related to the gravitational force, right? Main thing is just started from here. you have to divide this one. Okay, understand? You have to calculate by your own self, then you have to write the answer. Okay, understand? आपको डायरेक्टली इसमें से लिख नहीं देना है, आपको कैलकुलेशन करना होगा. Okay, and for another one example, it will be a homework for you. Example number, okay, example number 16 of exercise. You have to do by your own self. Understand? It is a homework for you.